Okay, so circle geometry. I'll find the circle again. Some things we need to know, basically. So the first thing is that with a circle, if I draw a segment, got my radius, okay, this angle here is always twice the angle fully to the edge of the circle. Okay, so this angle is 2A, this angle is A. So whenever we have a segment, the angle to the centre is always twice the angle to the edge. So there's a special case for that. Obviously we have the diameter. So if the diameter is a segment, basically we've got the angle to the centre is going to be 180, isn't it? So any angle we want to draw in a semicircle by connecting two lines up, we've got a diameter. Any of these angles is going to be 90 degrees. Okay, so any two lines coming from a diameter, joining from a diameter are going to equal 90 degrees. Some more 90 degrees coming as well, because if we look at a circle and we look at a radius. Now a tangent, we've not talked about a tangent yet, but a tangent's basically a line that just touches as it comes past a circle. So a tangent, that's what this is called. Tangent will meet a circle, will meet a radius at 90 degrees. Tangent will always meet a radius at 90 degrees. There's more. If you create a quadrilateral, any quadrilateral, in a circle, the opposite angles the opposite angles, so A plus B and C plus D, have to add up to 180 degrees. Okay, that only works for a quadrilateral that you can fit inside a circle, where all corners are touching the circle. That doesn't work for any other quadrilaterals. Only in a cyclic quadrilateral that all four corners touch a circle. Okay? Not much left. Okay, two tangents. Okay, two tangents will cross over at some point, and the line in the centre of the circle will bisect that, and we'll get two right angle triangles. Okay, we'll get two right angle triangles. This length, both being the same. Okay? So we get two lovely right angle triangles there. Okay, so one last thing, which I'll just pop up here. Alternate segment theorem. AFT. We've got our tangent here. If I create a segment, okay, and I draw something coming off it like this, I'll find that this angle here will equal the opposite angle inside. So A will equal B. That's called alternate segment theorem. So whenever you see something like this, those two angles must be the same. Now, all of these you need to make a note of They are in the booklet, but you need to write them out in your own writing. Explain, little explanations next to them so you understand them more, because you'll need them to answer questions, and we'll do a sample question now together. Okay, so as if by magic, our sample questions appeared. We've got this tangent across the bottom, we've got 40 degrees and 80 degrees here. So now we need to find all the other angles that we can. So, first off, we see that we've got angles on a straight line. So we know that 40 plus 80 gives us 120. Okay? And 180 minus 120 will give us that angle, which equals 60 degrees. So this angle in here is going to be 60 degrees. You can also see we've got an alternate segment theorem going on. So this here must be 80 degrees as well. Okay, we can also see we've got another alternate segment theorem going on here. We've got a segment here and an alternate here. So this must be 40 degrees. And we all could work that out as well, because we've got 80 plus 60 gives us 140, 180 minus 140 would give us our 40 as well. Okay, the other thing we need to look is we've got a cyclic quadrilateral here. So we know that this angle here must be 120, because opposite angles in a cyclic quadrilateral have to add up to 180 degrees. And we've also got this parallel line, so surely there's going to be something on here that can help us. Yes, there is. This line is cutting the parallel line, so we've got our Z angles. So this here must be 40 degrees. Which leaves us with the fact that this plus this must equal 180, or just that this must equal 180. So we get 120 plus 40 gives us 160, so this therefore must be 20 degrees. And it's that straightforward. There's lots of questions on cyclic quadrilaterals. There's lots of questions on circle geometry in the booklet, so get practicing on them again. Like the geometry questions, they're pretty fun, quite taxing, really get your brain working, and enjoy them.